In this video, we're going to review the 5 key equations for motion with uniform acceleration. So uniform acceleration means that an object's speed or velocity is increasing at a constant rate. And so that's what constant acceleration is. So it means the acceleration is unchanged. And that's what we're going to assume is true in all of these problems that we're going to look at. So there are 5 key equations that we're going to look at. They're all derived in your textbook. You don't really need to worry how they're derived, but if you're interested, you can check that out. It's helpful if you have your formula sheet handy because we are going to be looking at 5 equations, and it would be helpful if you have it handy. If not, please pause the video and jot down each key equation so that when we start looking at the examples, you can see why we're choosing the equation we choose. So here's the first equation. So it's set for determining displacement with velocity data. And we use this when we don't know our acceleration. So if we don't know our acceleration, this is a good equation to use. Obviously, you might not be solving for displacement. Maybe you're solving for your initial velocity. Doesn't really matter. We know how to rearrange equations. Equation 2 is used for determining final velocity. And you'll see that we don't have displacement. We don't have a delta D in this formula. Equation 3 is using to determine displacement using acceleration, but we only know our initial velocity, not our final velocity. Equation 4, determining final velocity with displacement data, and what you'll notice that's missing from this equation is our delta T. Our final equation is determining displacement, without your initial velocity. So this time we have VF instead of VI. So let's apply this to some examples. It's going to be really important to use the GRASS method when we're solving these problems to write down all of our given information and what we are being asked to find, because then we have to go and seek out which one of those 5 equations we should use. So here's our first example. Always a good idea with word problems to read through the entire word problem once and then read through it again, searching for your important information. So Ima Hurryin is approaching a stoplight moving with a velocity of 30 meters per second. The light turns yellow and Ima applies the brakes and skids to a stop. If Ima's acceleration is -8 meters per second squared, and just to pause there, the -8 means that it's slowing down, not that she's going backwards or in an opposite direction. Then determine the displacement of the car during the skidding process. So let's go back, reread, and write down what we know. So she's moving with a velocity of 30 meters per second. So that is our initial velocity. I'm just going to use V1 instead of VI. It doesn't really matter. So that's our initial velocity. The light turns yellow. She applies the brakes and skids to a stop. Stop means that our V2 is 0 meters per second. If Ima's acceleration is, so we have our acceleration, we're not going to worry about the signs right now. The fact that that's negative is really just telling us that it's slowing down. It's not really going to come into play too much with our calculations. And we're being asked to determine our displacement. So we are not given any time data. So what you want to do is you want to go back and you want to look at those equations and figure out which one doesn't have time in it. And that equation is this one here. So this is the equation that we're going to need to use. So we're going to need to rearrange it to get delta D by itself. So I'm going to show that. So we're going to start. I'm going to move the V1 over. So I'm going to subtract it. And then in my next step, I'm going to divide both sides by 2a. And then I will write it so that my required information is on the left side. So there is our equation. I'm just going to flip to slides so that we can put our information in. So I'm just going to jot down that equation again. So let's go ahead and put our information in. So delta D. So our final velocity is 0. Our initial velocity is 30, and and it's all over 2 times our 8 meters per second squared. And if you type that all in on your calculator, you get 56.25 meters. We want to round that so that we have 3 significant digits, because if you go back and you look at your given information, both your 8 and your 30 have 3 significant digits. So we'll round that to 56.3 meters. And we're not told if she's traveling north, south, east, west, so we're going to say forwards, because we do know that the car is going forwards. So here's our second example. Ben Rushin is waiting at a stoplight. When it finally turns green, Ben accelerated from rest at a rate of 6.00 meters per second squared for a time of 4.10 seconds. Determine the displacement of Ben's car during this time period. So we'll read through it again and we'll write down what we know. So he's waiting at a stoplight and he accelerates from rest. So that means our V1 is 0 meters per second. And we're told his acceleration is 6 meters per second squared. And he does that in a time of 4.10 seconds. And we're being asked to find his displacement. So have a look at your equations. You want something that doesn't have VF in it because we do not know his final velocity. So it's going to be this equation here. And since we're being asked to solve displacement, we don't have to rearrange this equation, which is nice. So we can just go ahead and put all of our information in. It's okay with me if you leave out units, just to save you some space. And then if you go ahead and you put that all in on your calculator, you'll get 50.43 meters. And then we'll check, we want to round so that we have 3 significant digits, because if you're starting from rest, 0 can have infinite numbers of significant digits. So we're going to round so that we have 3 significant digits. So it's going to be 50.4 meters. And our direction, we're simply going to state forward because we're going to assume that he accelerates in a forward direction from that green light. So that was a quick review of the 5 key equations for motion. So I only did 2 examples. All of your examples are going to be pretty much the same. Write down your given information, what you're required, and then go and check those 5 equations, figure out which one you need to use, and hopefully you can rearrange it properly.